Okay, picking back up on Test 11 Review Worksheet. In this video, I hope to cover questions 4, 5, and 6. Question 4 asks us to find the following values. Notice it specifically says in degrees, so we're not talking radians like we often do, we're talking degrees. So these are our inverse trig functions. On part A, we are talking about sine inverse. And as we talk about sine inverse, and cosine inverse and tangent inverse for that matter, you need to remember what kind of outputs or what kind of range values they're allowed to have. So first of all, sine, cosine, and tangent basically take our regular trig functions and reverse them. So when this says sine inverse of negative square root of 2 over 2, it's saying the sine of this value is equal to what angle? Now, when we think sine, do you remember those half circles? Sine inverse values are allowed to be over here on the right half of the circle. We traditionally say from negative pi over 2 to positive pi over 2. Since we're talking degrees, I'm going to say from negative 90 to positive 90. So all values have to be in there. When it says sine inverse of negative radical 2 over 2, well, first of all, recall that your positive quadrant is going to be up here in quadrant 1, and then sine is negative down here in quadrant 4. Think about your chart, and hopefully you remember that radical 2 over 2 happens at pi over 4, or 45 degrees. So if we wanted the positive one, we would be up here. But since we need the negative, we're going to be down here at negative pi over 4, or in terms of degrees, it's negative 45 degrees. And so sine inverse of negative radical 2 over 2 is negative 45 degrees. Okay, so and again, it's negative because we need to be down here in quadrant 4. Part B is cosine inverse. And when we think about our possible output values on cosine inverse, remember cosine is the one that is the half circle that is on top. We say that the output values for cosine inverse are 0 to pi, or in other words, 0 to 180 degrees. So when does cosine equal 1/2? Well, it's a positive 1/2, so that's going to be in quadrant 1, because quadrant 1 is our positive quadrant, and quadrant 2 is our negative quadrant. So if you go back to your chart, when does cosine equal 1/2? And I know that happens at pi over 3, or in other words, 60 degrees. Because it's positive in quadrant 1, it's 60 degrees. And then part C is asking us about tangent inverse. So again, think about your output values. Remember, tangent inverse is very similar to sine inverse in that we traditionally say negative pi over 2 to positive pi over 2, except I'm using degrees. So negative 90 to positive 90. The only difference is that negative 90 and positive 90 itself are not included. So it's up to, but not including those values. With tangent, remember quadrant 1 is going to be positive quadrant. Quadrant 4 is going to be negative quadrant. So we want when does tangent equal negative radical 3 over 3? And again, this is going to your chart, and you might practice filling in your chart before the test on Monday. But radical 3 over 3, you can think one is sine divided by cosine, going to be radical 3 divided by 3. And it happens at 30 degrees. Since we need to be down here in the negative quadrant, we're going to count down 30, and so it's happening at negative 30 degrees. so answer C is negative 30 degrees. Hopefully that's a good review of your inverse trig functions. Moving along to number 5. Number 5 is a review of some of our integral rules. It's asking us to take the integral of this these various terms here. Now, please remember this is an indefinite integral. There are no boundaries. So at the end, you will have to remember that infamous plus c. So, okay, integral of 3 over x. And if it helps, I know I like to think of my 3 over x as 3 times 1 over x. Sometimes it's a little bit better visual if I can pull that 3 out of there and see it as 1 over x. So what is the integral of 1 over x? And hopefully you're remembering natural log of absolute value of x. Putting the 3 out front, and this is 3 natural log of absolute value of x. Okay. The next term, we're doing the integral of 4 sine x. Well, I know it involves cosine of something. I know it's somehow cosine, and I know that 4 is there. So you have to ask yourself, and what I would say is the derivative of cosine, and when I say that, the derivative of cosine is negative sine. Since this is a positive sign up here, my integral, I'm going to say negative or minus 4 cosine x. The integral of 5e to the x, well, integral or derivative of e to the x is always e to the x, so this just continues on as plus 5e to the x. And then integral of x to the negative 6. Remember, when we're doing integrals, we add 1 to the power and divide by the new power. And so when we add 1 to the power of negative 6, it becomes negative 5. So we're going to divide this problem by negative 5. And generally we talk 1/5, and it's going to be minus or negative 1/5 x to the negative 5th. And then, of course, we're done with this integral. We don't have any values to plug in, so we say plus c. And I just boxed that because there's not really a lot of cleanup to do the way I went ahead and wrote it. Okay. Moving on to problem 6. Problem 6 is a limit. If it's the limit as x approaches 2 of this fraction, if we go ahead and plug 2 in right off the bat, I believe you get 0 over 0. And that is a limit that we can't leave as is, we can't deal with. So I would suggest you investigate any factoring options here. So let me rewrite it. The limit as x approaches 2. As we look at the numerator, x squared minus 4 is the difference of squares. So I can factor that. X squared breaks into x and x. The square root of 4 is 2, so 2 and 2. If it multiplies to be negative 4, I need to use a plus and a minus. In my denominator, I'm also factoring into 2 parentheses. X squared breaks into x times x, 2 numbers that multiply to be positive 4 and add to be negative 4. And that is negative 2 and negative 2. You will notice that we have a common factor of x minus 2. So x minus 2 in the numerator and x minus 2 in the denominator will cancel. When I rewrite this limit, it's the limit as x approaches 2 of x plus 2 over x minus 2. And as we go to look at this problem, and as we try and plug the 2 in again, we run into a slight problem, because when we try and plug in that 2, we end up with 4 over 0. And when you get that 0 in the denominator, you kind of need to investigate a little bit quicker, or a little bit more. Excuse me. What my brain is thinking at this moment is that this limit might be undefined. But I need to verify that. And so in order to verify that, my recommendation is that you check out the graph. If you go, and probably the best bet is to graph this on the graphing calculator. I don't have a real easy way to look at this. And so I would say graph it on the graphing calculator. I guess you could use our graphing techniques there. But when you graph this on the graphing calculator, notice x minus 2 is my denominator. So I have a vertical asymptote at x equals 2. My graph on the right is a positive function. So it starts here in the positive above the x-axis, runs up along the vertical asymptote of x equals 2. When we hop over that vertical asymptote, we're going to switch signs, and it ends up down below here. And what you need to look at as we try and figure out, okay, as x approaches 2. Well, as x approaches 2 from the right, you'll notice that my graph is going to go up to positive infinity. As we approach 2 from the left, my graph is going to go down to negative infinity. Well, going opposite directions means that this limit is undefined. My two sides of the graph are not going the same place, so my limit, is undefined. Okay. I think, you know what? I'm going to go ahead and put problem number 7 on here, just to kind of keep the video going a little bit. You guys can fast forward to the problems you need, I think. So I'm going to go ahead and put problem number 7 in this video. Okay, so this is problem number 7. And problem number 7 asks us to find the derivative. You will notice it is the derivative of a fraction. And so when we find the derivative of a fraction, we have to use the quotient rule. So if you remember the quotient rule, hopefully you're thinking about this right now, the derivative of the numerator times the denominator minus derivative of the denominator times the numerator, all over the denominator squared. So as I write this out, let's go for it. I'm going to write my derivative of y as dy dx. You could also write it as y prime if you want. I'm going to write myself a big old fraction bar, because I know I've got lots to write out. So the derivative of the numerator, the derivative of cosine x plus x squared. So the derivative of cosine x is negative sine x plus the derivative of x squared is 2x. I'm going to put that parentheses in quantity. That quantity in parentheses. So that's the derivative of the numerator times the denominator as is. So times e to the x plus 3. And then I'm going to say minus. And now we're going to reverse our situation. So now it's the derivative of the denominator. So derivative of e to the x plus 3. Well, derivative of e to the x stays e to the x. Derivative of a constant 3 is 0. So it's just e to the x. And then times the numerator as is. So I'm going to put in parentheses. So times cosine x plus x squared. All over the denominator squared. So all over e to the x plus 3 quantity squared. Now, I'll be honest, as I look at this, there is not a lot I can do with this. Yes, we could break it into two fractions, and that is one of the answers you'll see on the written out answer key. Yes, we could go through and FOIL and distribute in the numerator. But again, it's not going to accomplish much for us. I'm honestly going to stop here, and I'm going to leave my answer like here. I will give you a hint that the key, and I'm leaving it here because this is plenty helpful for what you'd be looking at the test. The key is to be able to come up with your answer and be able to identify it or match it with the form provided. So, hint, hint, you will be seeing a multiple choice question here. Okay, I'm going to stop this video here. Got 4 problems in this video, and I will pick up in another video.